Fermentation, a simple word that belies a complex and magical process. Humans have harnessed microscopic organisms to transform raw plant materials into fermented delights. From sauerkraut to wine, fermentation unlocks flavors, extends shelf life, and enhances nutrition. This ancient practice is experiencing a vibrant resurgence. Join us as we explore the fascinating world of plant-based fermentation. Alcoholic fermentation converts sugars into alcohol and carbon dioxide, essential for wine and beer. Yeasts, single-celled fungi, are the conductors of this process. Wine starts with ripe grapes, rich in natural yeasts. Crushed grapes release sweet nectar, beginning the must preparation. Yeasts feast on sugars, producing alcohol and carbon dioxide. Beer starts with barley grains. Malting activates enzymes to convert starches into sugars. Malted barley is mashed with hot water to create wort. Hops add bitterness, aroma, and preservation. Finally, yeast is introduced and fermentation begins. Vinegar, with its sharp, acidic bite, might not seem like a close relative of wine or beer, yet this tangy elixir owes its existence to a second fermentation, one that transforms alcohol into acetic acid. The process begins with an alcoholic liquid, typically wine, beer, or cider. Acetobacter, a genus of bacteria with a penchant for alcohol, takes center stage in this transformation. These bacteria, naturally present in the environment or introduced through a mother of vinegar, a gelatinous blob teeming with Acetobacter, oxidize the alcohol, converting it into acetic acid. Traditional vinegar production often relies on slow surface fermentation methods, where Acetobacter forms a film on the surface of the liquid, slowly converting alcohol to vinegar. Modern methods, on the other hand, utilize submerged fermentation, where Acetobacter is dispersed throughout the liquid, accelerating the process. The resulting vinegar, whether born from the slow dance of traditional methods or the efficiency of modern techniques, adds a vibrant tang to salad dressings, marinades, and countless culinary creations. Sauerkraut, a staple in many cuisines, exemplifies the transformative power of lactic acid bacteria. These microorganisms, found naturally on the surface of vegetables, thrive in anaerobic environments, converting sugars into lactic acid, which imparts the characteristic tangy flavor to fermented vegetables. Making sauerkraut is remarkably simple. Cabbage, shredded and mixed with salt, is tightly packed into a jar or crock, creating an anaerobic environment. The salt draws out water from the cabbage, creating a brine that inhibits the growth of undesirable microorganisms while providing an ideal environment for lactic acid bacteria to flourish. As the fermentation progresses, the lactic acid bacteria convert sugars in the cabbage into lactic acid, gradually lowering the pH and developing the characteristic tangy flavor of sauerkraut. The process typically takes several weeks, with the flavor evolving over time, becoming more complex and nuanced. Kimchi, a cornerstone of Korean cuisine, is a vibrant testament to the artistry of fermentation. Unlike sauerkraut, which relies primarily on cabbage and salt, kimchi embraces a symphony of flavors, incorporating a medley of vegetables, spices, and seasonings. While the specific ingredients vary widely, most kimchi recipes feature napa cabbage, radishes, garlic, ginger, gochugaru, and fish sauce or shrimp paste. These ingredients, combined with salt and often a glutinous rice paste, are meticulously layered and packed into jars for fermentation. The fermentation process in kimchi, similar to sauerkraut, is driven by lactic acid bacteria. These microorganisms, present on the surface of the vegetables and spices, thrive in the anaerobic environment, converting sugars into lactic acid, developing the characteristic tangy, spicy, and umami-rich flavors of kimchi. Fermentation, often perceived as a culinary art, is deeply rooted in scientific principles. Understanding the science behind these microbial transformations empowers us to create delicious and safe fermented foods. At its core, fermentation involves a delicate dance between microorganisms, primarily yeasts and bacteria, and their environment. These microscopic chefs thrive under specific conditions, requiring the right temperature, pH, and nutrient availability to perform their biochemical magic. The interplay between different microbial species creates a complex ecosystem within the fermenting vessel. For instance, in sourdough bread making, wild yeasts and lactic acid bacteria coexist, each contributing to the unique flavor and texture of the bread. The yeasts produce carbon dioxide, leavening the dough, while the lactic acid bacteria produce lactic acid, imparting a characteristic sourness and enhancing the bread's shelf life. Temperature plays a pivotal role in fermentation, influencing the rate of microbial activity and consequently the flavor, texture, and safety of the final product. Each microorganism has an optimal temperature range for growth and reproduction. For instance, yeasts responsible for alcoholic fermentation in wine and beer thrive at temperatures between 70 and 80 degrees Fahrenheit. Temperatures below this range can slow down or even halt fermentation, while temperatures above this range can stress the yeasts, leading to undesirable flavors and aromas. Lactic acid bacteria, the workhorses behind sauerkraut and kimchi, prefer slightly cooler temperatures, typically between 60 and 70 degrees Fahrenheit. Maintaining this temperature range ensures optimal growth and lactic acid production, resulting in tangy, flavorful, and well-preserved fermented vegetables. Troubleshooting fermentation, identifying and addressing common issues. Fermentation, while generally a straightforward process, can sometimes present challenges. Understanding common fermentation issues and their solutions is crucial for ensuring successful and safe ferments. One common issue is a lack of fermentation activity indicated by a lack of bubbles, a sign of gas production. This could be due to insufficient yeast or bacteria, unfavorable temperatures, or a lack of fermentable sugars. Solutions include adding a starter culture, adjusting the temperature, or adding a source of sugar. Another common issue is mold growth, often appearing as fuzzy, white, green, or black patches on the surface of the ferment. While some molds can be harmless, others can produce toxins, rendering the ferment unsafe for consumption. Preventing mold growth involves maintaining proper sanitation, ensuring anaerobic conditions, and using the correct salt concentration. The art of fermentation, mastering the craft through experience. While understanding the scientific principles of fermentation provides a solid foundation, mastering the art of fermentation requires experience, observation, and a willingness to embrace the unexpected. Traditional fermentation practices often rely on intuition and sensory evaluation, passed down through generations. Experienced fermenters develop a keen sense of smell, taste, and touch, allowing them to assess the progress and quality of their ferments. Experimentation is key to unlocking the full creative potential of fermentation. Varying ingredients, fermentation times, and temperatures can lead to a world of flavor possibilities. Embrace the element of surprise, for fermentation, like all living processes, is inherently unpredictable and full of delightful discoveries. The nutritional alchemy enhancing digestibility and nutrient availability. Fermentation, beyond its culinary appeal, offers significant nutritional benefits, enhancing the digestibility and nutrient availability of plant-based foods. During fermentation, microorganisms break down complex carbohydrates, proteins, and phytic acid, making these nutrients more accessible for absorption. For instance, the fermentation process in sourdough bread breaks down gluten, making it easier to digest for some individuals with gluten sensitivities. Furthermore, fermentation increases the bioavailability of certain vitamins and minerals. For example, the lactic acid bacteria in sauerkraut and kimchi synthesize B vitamins, including B12, which is not naturally present in plant-based foods. A celebration of fermentation, embracing tradition and innovation. Of fermentation, an ancient practice deeply intertwined with human history and culture, continues to evolve, embracing both tradition and innovation. From traditional kimchi makers in Korea to craft brewers in the United States, fermenters around the world are pushing the boundaries of this ancient culinary art. As we delve deeper into the science of fermentation, we gain a greater appreciation for the complex microbial ecosystems that transform raw ingredients into culinary delights. This understanding empowers us to refine traditional techniques, experiment with new ingredients, and create novel fermented foods and beverages. Let us celebrate the transformative power of fermentation, embracing its rich history, scientific depth, and endless culinary possibilities. By nurturing our connection with these microscopic allies, we unlock a world of flavor, nourishment, and cultural heritage.